Right now I'm in Roorkee, and today I'll be talking about, or in fact, introduce you to a slightly new platform to do various quantum technologies. But before that, because this lecture series is on quantum sensing, what we will do, we'll take a very quick recap on sensors. And for that one, I'm just to avoid redundancy, what I would prefer highly is if from the audience I can, especially the student audience, who can just quickly answer me some of these questions. For example, what actually sensor is. So if you would like to answer, please unmute yourself, and can you answer me or tell me what sensor is?
Yeah, participants may use the hand raise feature. We'll then unmute.
So we'll just take 5 to 7 minutes on this part, and then I'll directly get into the
No
main
problem.
content.
So any participant want to answer, please raise your hand and we'll give the mic feature. Or if you are not available, then please write in the chat box. We can also moderate from here.
Sure. Just to avoid the one-way communication, which can get boring at some point. So, hello. No one.
There are some messages coming up.
Okay, messages.
Without touch anything, or one more, a device that detects one more response. It's a detector that take advantage of the behavior of atoms and photons at the quantum level.
Mm-hmm. So the question basically is what a sensor is. Generic, very generic. So you rightly mentioned devices, or a device that basically detects some physical quantity. Sensor is a device that detects the physical, chemical, or biological stimulus and convert it into measurable electrical signal. It can be electrical or some other signal as well. So that's good. And then from sensor, we can move to the types of sensors, classical and the quantum sensors, right? So the classical would be where if you are talking about a particular sensor, you can understand the overall working principle or the behavior, everything, just by applying the classical phenomena or whatever information we have from the classical physics. Yes. And then when we're talking about the quantum sensors, that's when, even to understand the system, we need to use the principles of quantum mechanics. So any system that needs explanation from quantum mechanics would be categorized into quantum sensor part. Okay, that's good. So with that, we can move. And then if we talk about various examples, so then perhaps now we can focus more on the quantum aspects. So quantum sensors that are currently quite popular are basically, one could be our atomic clocks that helps in basically measuring the time with very high precision. Yes. And of course, when you talk about precision, in previous few lectures, you went through the Heisenberg limit, which is the theoretical limit, and that tells you how precisely you can measure a quantity theoretically. And then there are experimental limitations, and that's what over the period of time we are trying to basically to work on and increase the sensitivity of our sensors. And apart from atomic clocks, one would be NV centers, quite popular these days. And the major application is found in terms of measuring very small magnetic fields using NV centers, and that we will also briefly look into how exactly that can be done. And when we talk about any sensors, we basically have to put a lot of emphasis on the material engineering and material science aspect of it, because any sensor will be based out of some material. So whenever we are trying to develop any sensor, we need to understand the material science and material engineering aspect first. So with that, what I will do during my presentation or lecture, I will uh, back and come back to the sensor aspect whenever I'm introducing something, and which connects directly to quantum sensing. Otherwise, my goal here is that I would like to introduce you to a new quantum technology platform, which is basically at its core, it's a material platform that I will introduce. I will speak about how to make such materials in order to do various quantum applications. So, namely, the outline would be color centers as potential qubit candidates. And of course, I will explain what color center is, what a qubit is, and then how to make these color centers or qubits, and then how conventionally people have been making them, and what are the challenges associated to those conventional techniques, and then what we have recently done as a new thing to overcome those challenges. And then I'll also introduce you to a new kind of mechanism called the laser ion doping, which is a new technique to do ion implantation. Ion implantation also plays a critical role in many of the quantum technologies that you may have come across. And then finally, I'll talk about the programmable formation of quantum emitters in silicon and their applications, and briefly also about superconductivity in ion implanted boron doped diamond, which then potentially can be used as a quantum sensor. And in the end, I'll conclude all my work and the lecture. So let's begin with the introduction part. So whenever we are talking about quantum information science or quantum information processing, essentially what we are talking about is basically, if you have a quantum information, how you process it, meaning how you manipulate that information, how you propagate that information, and so basically that will lead to quantum communication, networking, sensing, etc. And to do any of these applications, the fundamental unit that you need is what we call as a quantum bit. So if you try to compare it with a classical bit, our classical bit can be realized simply with the transistor, where the on off state gives us the ones and zeros, and we work in the binary form. So that works really well. And the Moore's law basically suggested us that every 2 years, if you look at the bit density, it will get doubled. Uh, to be precise, every 18 months. And then now we are going to a saturation of that Moore's law, where we need to find new technologies, new platforms, new sensors that can overcome those challenges faced by the classical techniques. So one major technology is the quantum technology, where the fundamental unit is qubit. And qubit, when we talk about the experimental realization of any qubit, what we essentially need is basically three different prerequisites. One is your qubit needs to be quantum mechanical in nature, and meaning that you should be able to use principles of superposition, and eventually you should be able to do quantum entanglement on your system. And along with that, the system should have a distinguished two states, once that can be defined as 1 and 0 when we finally detect. And now, if you talk about how people have been realizing that experimentally, there are a bunch of platforms. One of the most mature technologies where we use superconducting materials, make various types of oscillators out of it. The most mature platform within this technology is the transmon qubits. And then we have other techniques like ion traps, or quantum dots, or color centers, etc. So without getting into the like fine details of these platforms, the main point here is that all these follow those three requisites, and hence can be used as quantum platforms. Today, my main focus will be about color centers. And when I say color center is basically nothing but atomic level point defects in materials. So you take any material. Ideally, we would like to have 100% pure material, meaning if you, let's say, take a silicon lattice, then we should only have silicon atoms inside the lattice. But in reality, every material carries some defects with it. So these color centers are basically nothing but those defects. And in the past couple of decades, people have basically named them defects because defects were unwanted. They were basically destroying the properties, that properties of the host material that we were interested into. But now what it turned out is that if you can reliably, nicely make those color centers or defects in these materials, you can actually realize them as qubits, because they follow those three requisites that I just mentioned. Here, this table is just a comparison table for different quantum platforms. So whenever we are talking about any platform, these are some of the issues that we need to deal with. For example, scalability. Uh, and this is something that is being that has been a challenge for uh, all the platforms that we have so far, in one way or the other way. And then other aspect is the controllability. So if you can make a platform, you can make your qubits. How well can you control your qubit? You should be able to manipulate the quantum states with external stimuli. At the same time, you need to make sure that the quantum state is not simply getting changed by your unwanted stimuli or unintentional stimuli, which might also always be there. And this is what leads to also noises, and that we still need to work on. And the other aspect is the long spin coherence times. Again, it's related to the noise. Most of these quantum systems we have till now, they have sources of noises, and that basically then negatively influences the spin coherence times. So when I say spin coherence times, meaning if you, let's say, put or start with a particular quantum state, then your system should stay in that quantum state until you are done with whatever operations that you are performing with your system. Yes, because otherwise, if in between you are losing the quantum state, then basically you cannot rely on your results. The other aspect is, if you're talking about scalability and you're trying to make a full-fledged quantum system, then it should be easy to integrate it with other platforms like photonics and electronics. Then you can make a full system. And with that, I will briefly give you a literature review about what's already been done in the community when it comes to color centers as quantum technology platform. So in the right side, if you see, the graph basically represents the fiber attenuation and then wavelength on the x-axis. And what you're seeing is basically different materials and the defect centers coming from those host materials. So NV center is being one of the most popular and widely known defect. Then we also have silicon vacancy center in diamond. We have other vacancy centers in silicon carbide, and so on and so forth. Essentially here, what I would like to emphasize is that the x-axis here basically represents the emission wavelength of these color centers, because these color centers or defects, they are basically optically active, meaning if you excite them with lasers or electrically, or there can be many ways to excite these color centers, eventually you get a photon out of it. And those photons, they will certainly have a particular wavelength. So if you look at the NV center or silicon vacancy centers, they basically have emission in the visible range, which then brings some benefits as well. But then if you talk about some particular applications where, let's say, you have to have a long distance communication, if you want to establish that, then you essentially need a photon that is in the telecom band, because that's where you can easily use optical fibers, and optical fiber will have less losses in the telecom band. And basically the other also popular candidate color center candidate is these defects in HBN, hexagonal boron nitride. And here, why I would like to emphasize this is because the telecom band is of our interest, and then now the question is what material can give us defects or color centers that can emit the photons in the telecom band. So, but before that, I'll just quickly summarize about the NV Center and how it actually enables different quantum sensing applications. So, if you look at NV Center, it's basically, as you perhaps already know, it's in the diamond lattice, you remove two carbon atoms, you place nitrogen in one place and keep the vacancy there for the other atom positioning. So this way, this makes NV nitrogen vacancy center. And the interesting aspect about this NV center, if you look at its band structure, so you can realize it as if you have a wide band gap for the diamond, in somewhere in between the band gap, energy band associated to your NV center. And then you can basically excite this NV center with lasers or microwaves. And 0, 1 here are basically just the energy level. So ground state, from ground state you can excite. And then what happens here is that due to its interesting structure, and as you know, the nitrogen is basically the pentavalent dopant. So it will carry an extra electron with it. And that basically leads to a single spin that is there with the NV center. And now because we know that electrons and photons, they are quantum mechanical systems. So now what we can do, we can simply play around with the spin state. We can tune the spin state, and we can realize different quantum applications. In this particular case, what people have been doing is they basically exploit this ground state triplet property associated to the NV center, which basically provide us this Zeeman splitting in presence of any small external magnetic field. Uh, so basically this ground state triplet plus minus 1 here, if you have any small external magnetic field, it will split into ms plus 1 and minus 1, and that is what leads to these sensing applications. And then you can find applications in many different areas, not just for to make a magnetometer out of it, but even for biological applications. We have been exploring this material platform. Now, coming back to where we need a material that can emit photons in the telecom band, so that we can then think of many other applications like the long distance communication or even sensing that requires even more precision. Yes. So when it comes to the material platform, silicon is definitely a material of choice because all our CMOS technology is based out of silicon. We know the most about silicon. Silicon is among the most pure material that we have so far, and hence it is easy to work with silicon. We if we can make, let's say, different starting with quantum sensors or and eventually quantum computer out of silicon itself, then it will make our life easy because we do not need to go through a paradigm shift in terms of the infrastructure that we already have from the CMOS technology. And as I already mentioned, that the photons emitted using the silicon defects are in the telecom band. So that's already a benefit. Now, what you're seeing on top are basically different point defects that are there in silicon host material, and with their respective emission wavelength. So one of the most commonly formed color center in silicon, which is, you can say, analogous to the NV center of diamond, is the G center. And this color center forms when you basically slightly displace the silicon atom from its lattice side to interstitial side. And then if you introduce two carbon atoms at the substitutional sites, now this group of three atoms 2 carbon, 1 silicon interstitial. This forms the G center, and if you can drive it using lasers or microwaves, you can basically get a photon out of it, which is in the telecom O band. Now, similarly, the C center forms when you simply have one carbon atom connected to a one oxygen atom, and that has an emission wavelength of 1570, which is in the C band of the telecom band. Even within this telecom band, C band is the most desirable band. And then very simple structure based defect is what we call as CI center. So you just simply introduce a single carbon into the silicon lattice, and this center itself, this atom in itself is a color center or a qubit. Another really popular color center in silicon is the T center, which forms when you have two carbon atoms, one silicon, one hydrogen, and a free electron in the vicinity. So this kind of structure also is widely known, and also it comes in really handy because of this free electron. And now you can do the similar things as you do with the NV center, because you have electron spin and you can exploit that. Now, when it comes to making these defects, the reality is that it's easy to make some of these colored defects. In fact, at times it's difficult to avoid them, as the name itself also suggests. Now, the main challenge is how can we reliably form them with high quality at desired locations in the lattice? Because if we can do that, then we can also connect, let's say, these defects to other components in your system and make real good use out of it. So this part we have already in some sense covered, that we need the telecom band emission, we need so in some sense these color centers you can also consider as quantum emitters, because they are eventually giving you single photons. And then the other aspect that we need to take into account is what is the intensity, how many photons per second are you getting. That is one parameter that we need to take into account. And then line width, so the emission, how sharp the emission is, because that eventually also affects many other critical properties, and similarly the spin coherence time and the lifetimes. Now about the formation, the most conventional way people have been using is ion implantation, and then followed by thermal annealing. Ion implantation is to introduce those foreign elements that we would like to have eventually in the structure of our defects. So we need to introduce those foreign elements first, and that we can do by doing ion implantation. And then when we do ion implantation, it creates damage inside the lattice by the nature of the ion implantation itself. You can understand this part. And then to heal that damage, we need to do thermal annealing. So this is basically the most conventional way people have been using. One could also use different other types of irradiation, for example, proton irradiation. So if you just shine energetic protons onto your silicon, it can already make some of these defects. If let's say some carbon hydrogen is already present in the silicon lattice from storage, because these are just hydrocarbons, they can basically diffuse into your materials as well. So you can simply do proton irradiation, you can move around these atoms a little bit, and then that can easily even make these color centers. You can do similarly with electron beam irradiation as well, or different types of plasmas. And then ion beam is, I think, somewhat redundant here, as I already mentioned. And then lasers as well. The laser aspect is, I would say, somewhat new, which I will also discuss in little detail soon. So basically, conventionally, people do, as I mentioned, ion implantation and rapid thermal annealing. And this was only in 2020 for the first time. It was reported that you can actually make these defects at single center level, meaning that if you're talking about the G center, which forms with those three atoms, two carbon and one silicon atom, so you can now actually just have those three atoms. Otherwise, in the past, what was happening is you have these defects in clusters. So many of these defects were there in one particular position. And if you look at the emission of this kind of cluster of defects, or we also call them ensembles of color centers, that is basically not a pure single photon source. So you cannot do many quantum applications with that kind of system. So here in 2020, we saw that we can actually isolate those defects in silicon. Of course, at this stage, they are randomly oriented, which you can also see in the raster scan. The bright spot basically tells you the emission intensity, and then each of these bright spots are single G centers here. The corresponding spectra is, as you can see in figure C, and B is something that I will explain maybe a little bit later. This is called the second order autocorrelation measurement. This is basically the ultimate proof to show that indeed the quantum emitter or the photon source is a single photon source. And then what one could do is we can play around with different parameters, like when we are doing the rapid thermal annealing, we can change the annealing ambiance, we can change the annealing time, etc. So if we do this kind of parameter scan, we can get some flexibility in terms of the properties of the color center that we are making. For example, if you look here, we did this work where we varied the annealing time, and you can see that the annealing temperature here was kept constant at 1000 degrees Celsius. And if you are in this window of uh, up to 5 seconds, then you always just make ensembles of G centers, meaning cluster of these G centers. And then if you are outside this window, then there is a range for the annealing time where you can get single G centers. So it gives some sort of fine tuning. Then we also did this other work where we shine directly our silicon material with high energetic proton pulses of about 10 nanoseconds. And then we also looked into the emission spectra, so which means the quality of the G center. And that also gave us this insight that indeed, even with the simple proton irradiation, you can make these G centers and you can tune slightly their properties. And this is simply playing around with some other parameters that we can have access to, for example, the fluence of the proton, and then how that compared to if you, let's say, you have a continuous pulse of protons um, instead of your short proton pulse. Now with that, I'll move to another platform which can be used to basically synthesize these defects, and also some other aspects that I will mention now. So this is something called laser ion doping, or the other technical term which is more popular or widely known is laser plasma ion acceleration. In TNSA regime, which stands for target normal sheath acceleration. What happens here is that you start with extremely high power lasers, and these are, when I'm saying high power, they are in the petawatt power range. So if you look at like for comparison's sake, our laser pointer that we use all the time during presentations, that laser pointer is hardly a few microwatt to milliwatt power, and also it's a CW, continuous wave. And here we are talking about petawatt, 10 to the power 15 watts, instead of that pointer which was 10 to the power minus 6 to minus 3. And with the pulse duration of a few hundreds of femtosecond. So you have this high power for 10 to the power minus 15 second. So we are talking about extreme conditions here. And if you shine such powerful laser pulses onto different materials, for example, that could be a target foil, a thin foil made out of different materials. In this particular case, we were using boron based foils. So if you shine this laser onto your boron foil, what happens is it will ionize it, and that will create the boron ions, and also photoelectrons. And this is what also leads to a sheath field, extremely intense in the range of mega electron volt. A sheath field will be generated because the because the electrons will move faster compared to the ions, heavy ions, and that will leads to this transient intense electric field, and this electric field can then accelerate your boron ions, if you want to understand that way. And then what you can do, these ion beams you can use to implant into various materials. Now you can think of asking this question, why you want to do ion implantation at such extremes when there are better commercial instruments available to do ion implantation nicely, which we have been uh, using for a few decades already, for CMOS technology in order to make the PA and etc. Regions, right? So here the idea is, because everything is happening at extreme conditions, it can actually lead to see new phases that are there in different materials. Uh, for this particular kind of technologies that where we want to make defects, what happens is that if you're working with these extreme conditions, it can actually stabilize some of the color centers or defects that were actually not possible to make with the conventionally used ion implantation and thermal annealing processes. So that's one unique aspect about this. And the other aspect is, using this kind of technique you can make quick devices. For example, let's say you start with a silicon substrate which is of n type, meaning the phosphorus was dropped into it, and then you use a boron foil and you basically implant boron into this n type silicon. Now what you can do on the very top, by the nature of this particular regime, the target normal sheath acceleration, you will end up having um, yeah, so this is basically the real experimental data. If you look at n-type silicon, and after the boron implantation, um, the boron concentration that is there in your silicon material is as shown here. So top few hundreds of nanometer is where you have about 2% of boron into silicon, and then the profile, as you can see, is like this. So up to, say, few micron, you have certain concentration, and so forth. So what you end up getting is, starting with the n-type silicon substrate, for the top few hundred nanometer you have highly p-type silicon now, and then somewhere in between where you have some boron and some phosphorus is the region that you can consider as nearly intrinsic. Of course, the pure intrinsic would be when you don't have any of these elements. And then this actually gives you right away PIN light emitting diode uh, that is based out of silicon. Why? Because when we are doing this kind of processing, we are also implanting some other hydrogen and carbon elements that will lead to the formation of these color centers. So you not only have this PIN diode, but also these color centers embedded into your diode. Now you can bias this device, and you can try to look into your quantum emitters that you have just formed. So using this kind of processing, what we saw is you can easily make these particular defects. For example, the W center, it basically forms when you have three silicon interstitials together. Then the G center, the most commonly formed, and the C center with one silicon and oxygen. Now, the way we probe these things is by using photoluminescence. So it's basically a technique where we drive these color centers with lasers. So you can see we have the CW laser here. Generally, it's a green laser 532, but you can always use telecom band lasers as well if you want to see things at resonance. And then you can basically let your beam go through uh, your price station unit all the way to your specimen, which is your silicon sample here. And then the emission you can collect. In our case, we did this kind of measurement in two phases. So in one case where we would like to see the emission as a function of wavelength, to know what exactly this color center is. So then we can send out this emitted signal to your spectrometer, which basically use the gratings to distinguish different wavelengths, and hence we can get this kind of nice photoluminescent spectra. The other method that we use is when we send the emission to more sensitive detectors called the SNSPD, which stands for superconducting nanowire single photon detectors. And these are basically the instruments that eventually help you understand things or different properties at single photon levels, which again I will explain briefly how it actually works. And then we did some DFT calculations for theoretical support, which basically tells us that how the strain that is there in the material itself can also change the spectral properties or some other line width or lifetime properties associated to these colored centers. And then again, as I mentioned, this is the second order autocorrelation measurement. So what you essentially do to actually check if your source is a single photon source or not, you basically take the emission from your emitter, and you basically split your emission into two parts. You send that to two different detectors, both are single photon detectors, and then you basically use a timing circuit to basically measure at what time instance you received any photon from both the detectors. So if, let's say, your system is a single photon source, then of course after this beam splitter, it can take only one of the path. It cannot go through both the paths, right? So at a time you will only see that there is a click from one of the detector only, and those are the time instances. If you take average of that, you can basically see that um, the signal should go to zero, because if you take, let's say, the multiplication of both the detectors, and if the source is your single photon source, so then one of the detector will say click, other will not receive anything. So you will eventually get a zero out of it. But if both the detectors are sensing something, then that's what define your background level here. And now if you do the normalization, and your signal here goes below, so this is a raw data, not normalized. If it goes below zero point 0.5 for the second order autocorrelation function, that's when we say that the source is a single photon source. Now we can briefly look into how a single photon source works. So if you look first into the classical counterpart, which is a simple, you can take any photodiode. How it works is, you start with your photon. When the photon arrives on your detector, you create electron hole pairs, which then converts to current, and it works really well at room temperatures. And but then it's limited to its sensitivity and noises. So you cannot use the classical conventional photodiodes to detect single photons here, because even the noise level is so high here that you are not even sensitive to single photons. So that's when we need these kind of sophisticated superconducting nanowire single photon detectors. What essentially it is a superconducting material, meaning where the current flows without any resistance. And what you can do is, let me also check the time. Sorry, just give me 1 second. Yes. So what you can do basically is, uh, let's say we have that emission from here, yes, and when it arrives to us, the detector, so the arrival of the photon, it will basically create this hot spot, and this material from that special position will go from the superconducting phase to non-superconducting phase, or normal state. And this basically, now corresponding to this, you can this is the uh, basically the equivalent circuit. And if you just probe the voltage difference, it can between the superconducting and the non-superconducting phase, it can basically tell you when the photon arrived. And this helps you eventually in characterizing the single photons. And this is just, the rest is the mechanism to recover back the superconducting phase. Now, as I mentioned, we had this PIN diode with these color centers, and this basically plot shows you, based on the bias voltage, how the emission is from different color centers. So the three centers we talked about, W, G, and C, and this is how the emission is. So in this case, we did not use any laser to excite these color centers, and instead we did it electrically, which comes in handy if you are trying to make some nanoscale devices, where if you have to always use lasers, then lasers will be limited by the diffraction, and compared to that, in the electrical case, you can always make nanoscale features. And similarly, because you have this diode structure now, instead of being in the forward bias where you're letting the electrical current pass through your device, you can also use it in the reverse bias where no current passes, but you can provide electrical field. And that electrical field is similar to your Zeeman field, which happens when you have external magnetic field. Now if you have electric field, you can also see the shift, and which we define as the Stark shift, and that's also what we observed. Now, in the interest of time, I will quickly mention the most critical aspect. So, in the beginning, I was mentioning about the need to make these color centers deterministically with high quality at desired locations. So, here is basically our idea. What we recently did is we slightly changed the conventional approach. So we did ion implantation, we did thermal annealing, but this time during the thermal annealing, instead of using inert gases as an ambience, we use forming gas, which is basically 10% had 10% of hydrogen and 90% of nitrogen. And this way we introduced some hydrogen in the silicon lattice during the thermal annealing step. And what it basically led us to see is an emission at 1450 nanometers. And there was no emission around 1280, which is basically for the G center. And the G center is, as I mentioned, is most commonly formed color center. So you do any sort of irradiation and you always pretty much get the G center. And that kind of dominates all the other color centers to form. And in this case, what we did by using this slightly different recipe for formation, we could actually passivate this most commonly formed G center while making a more interesting center called the CI center. And then what we did is we locally came with femtosecond lasers. This time these femtosecond lasers are of really low energy per pulse, okay, like in the nanojoule energy range I'm talking here. And then we can locally change the configurations of our elements inside the silicon lattice, and we could erase or form these color centers at desired locations. And this was basically the major highlight. And then the other main highlight was we could also make these color centers at single center level. And this is basically the proof that we indeed have single photon sources here. And these sources, as I also mentioned, if in their structure they have some spin degree of freedom, they qualify not only to be called as single photon sources, but also spin photon qubits, because you have the spin, you have the photon, and you can directly basically use it for qubit operations. Now, sort of summary here for that part. So we have basically explored various conventional as well as non-conventional methods to synthesize different quantum emitters. Um, and we can also make them reliably at local positions using a slightly different conventional approaches, along with integrating femtosecond local annealing into the picture. And also other recent work that we did was embedding these color centers into various platforms. So PIN being the electronic platform, which I already mentioned about. Here what we have done is also embedded it into photonic cavity, and also waveguides more recently. So what that helps when you put this kind of color center in a photonic cavity is you can enhance the emission rate, which at some point in the beginning I mentioned that it's also critical that the photon we get more photons per second to have better sensitivity. Now, just to summarize, basically, I have introduced you to a new platform, which is these color centers coming from silicon emitting photons in the telecom band, and then how to make them reliably using basically a wide range of parameters in the conventional and the non-conventional regime, and also embedding those color centers into electronic and photonic platforms. And with that, I would like to thank um, for invitation first, and now I can also for the audience for your attention, and now I can take few questions.
Just nice likeness. It was a nice talk. And yes, there are.
Okay, let me go over the chat section, and I can see. This is- so I think from 314 something would be for me. Photoluminescence, sensitivity, magnetometer. I think those are the answers that people gave in the beginning, but I am not seeing any new messages.
Sensitivity is sensitivities.
You are actually not audible. I'm not able to hear you properly.
So this
Should I close my camera perhaps, if that helps?
is
No, I cannot hear, but I think I briefly heard you said sensitivity. So you are talking about photoluminescence sensitivity.
Yeah,
Yes.
actually, this
So
photoluminescence sensitivity thing.
okay, I cannot hear you properly, but I can try to guess what exactly is the question and then answer accordingly. So, in the chat section, somebody has written photoluminescence sensitivity. So that can be looked into in different ways. One would be basically the collection efficiency. So, how well can you collect? And then for the sensitivity aspect, it will depend on the detector side. So if you, as I mentioned, we take two parts. One is this single photon superconducting. Hello. Uh, Let me try this way. I stopped my video. So basically, in terms of sensitivity, we can, if you talk about the detector, the superconducting single photon detector, so they have basically efficiencies around 90 to 95 percentage as well. So that's one aspect. Then the other is, if you are looking at the PL spectra part, then that depends on what kind of cameras that we have used. So in this particular study, we were using Indian gallium arsenide based cameras. They are not popular to be used in the telecom band, and there are even better options to use. And then another aspect to look into this issue is how well can you even collect the photoluminescence from silicon, because silicon again is basically not a material that is known for light emission. So that is another aspect of looking into it. Let me see if there are any other questions. Built how cost effective, or should we go for cloud based transfer of? So when you say inbuilt QC, quantum computing, or it's you mean something else? And then get the output of the analysis. Well, there's a question about quantum radar, which is okay. So just to answer that first part, sensors with inbuilt quantum computing are cost effective. So of course, that's one of the challenge. Eventually, what we would like to do is, now we have a quantum emitter, and then right now we are doing we are taking the emission through optical fibers and free space as well to some extent, and then eventually leaving taking it to the photo detector part. But eventually we would like to have the source and the detector and everything in between on a single, at least if not on single chip, then basically as a common system. And that is something that many companies and many people at research level also working on this part. So if I speak particularly for the silicon case, there is a company based out of Canada called Photonic Inc. Inc. And they basically have this prototype to have in one assembly the quantum emitter aspect. So the silicon chip will sit there, and then the SNSPD is the detector part, and in between your waveguides, photonic cavities, etc., and optical switches, etc. So they will come as a full package, a single system, and that is definitely much needed. So somebody asked a question on quantum radar, how and what technique used. So this perhaps I would not be the best person to answer, but I can try. So the main, I think the difference here would be that you would instead of like you will basically use a single uh, photon here instead while you are collecting your radar data. uh, the information carrier here is your single quantum systems, instead of using the classical let's say your CW laser if you're sending out and you're detecting. So instead of doing that, if you can do things with single photons, that will be desired. I think that will go for LiDAR case, not radar case. But I think for radar, perhaps the previous speaker would be the best person to answer.
Okay, madam. So I have not many other questions.
Mm-hmm. Sure.
So
Okay, I would like to thank again
any
to Professor Manoj and for the invitation.
thank you so much, madam, for joining us actually, and giving
Okay, should I head out?
quantum science. It is up to you. If we are now heading towards the valedictory session,
Okay,
so because this was
sure.
the last talk of the course, so it will be better if you can stay with us for some more time to listen to the participants' feedback, and we also thank
Sure.
every. Hmm.
Sure, sure. I'll stay for some time, and then I'll
Yeah, we'll start
basically.
sharing the screen from our side.
Okay,
Okay, thank you, ma'am.
sure. Thank you.
Yeah, actually, you will be able to listen to the participants' feedback also. That's the
Yes.
thing. And other resource persons also have joined. Yeah,
Okay, okay.
welcome.
Okay. So, good afternoon, everyone, and welcome to the validity session for the FDP QT-07 on quantum sensing. I, Dr. Manoj Kumar, welcome all of you on behalf of EICT Academy MNI, Co-Chief Investigator, EICT Academy, Dr. E.S. Pilli is with us. I also welcome my joint principal coordinator and all the experts on QT-07. It was started on September 26th, and today on October 17, we had the process gives experts from various IITs, universities, industries from abroad and across India. So I would like to both from IIT, Dr. Asba Dr. Rao Yella, and Dr. Tarun Datta from University of Hyderabad, Dr. Richa Goyal from IBM India, and Dr. Mohammad Noman from Waveride Instruments, Canada. This FDP, total 752 participants attended this FDP, out of which 584 were faculty members and 8 PhD students, 24 industry personnels, 24 PG students, and 16 students and other participants. So altogether 752 participants. These participants participated through IIT Jaipur, AICT Academy MNIT Jaipur, AICT Academy from IIT Kanpur, AICT Academy from IIT Guwahati, AICT Academy Triple IT DMJ Jabalpur, and AICT Academy NIT Patna. So this FTP has not only been a training exercise or set of lectures, but it was a collective intellectual journey of all of us through the experts on quantum sensing, magnetometry, noise limited detection, and I hope participants have gained a deeper understanding of how quantum can organize the real world sensing and instrumentation across diverse sectors from healthcare, environment, defense, including the fundamental science. So I welcome you all for this session, and I'm thankful to all of you for joining with us for this FTP. Now I would like to invite Dr. E.S. Pilli, Co-Chief Investigator, AICT Academy, Jaipur, to give a overview of the activities here at EICT Academy. I'm an IT doctor.
Yeah, thank you, Dr. Manoj. Thank you for this time, and thank you for this opportunity to share a few thoughts. It's a joy to be with you all again here. I was quite not present in this course as much because they are capable hands here. Dr. Manoj and Dr. Kamlender both are handled the whole program very well, and we have very good resource persons who have shared extensively. It is also kind of a 07, if we add, there are about 170 of them have completed all 6 courses. And those who have missed the other courses, there's an other alternate series that has started. So we are taking forward. So totally, if you count all the courses individually, there are about 6,000 people, more than 6,190 participants actually in all the courses who have registered and who are certified are about leaving the QT-07. If you look at about 4,700, and if you count QT-07 also, maybe about 600 of you will qualify. So there about 5,300 have been certified in various courses. So that's a very one of the things more the parties are present. So if you have 750 participants, there are about 500 plus joining every day as we look at the attendance. Though at a given instance of time, there may not be 500 present, but in the whole 2 hours attendance, as we look at, there are more than 500 who have logged in. Maybe there is some issues, there is some meeting, maybe so some people are on and off. So and about most of them were what do you call faculty members also. So that teachers are industry and participants are also from industry. That's a very unique unique case in this case. I hope my voice is breaking is what they say. I hope I am clear now. I was a little away from the system. So and I also want to note that the speakers are increasing to be better every day. We have had from coming from IITs and triple IT. We have Dr. Ashwath Babu, who has taken most of the lectures, and you all have enjoyed. So I hope that is a very good thing to happen. And I am looking. Am I audible now? Yeah. Okay.
Yeah. Okay.
Thank you. So let's yeah, right. Okay. Yeah, I would also like to express my thanks, especially to the speakers who have done. I have thanked Dr. Ashwath Babu, who has taken many sessions. Dr. S.K. Jain has taken many active sessions, and it's yeah.
I think SK Jain is
Triple ITTM Jabalpur, yeah. Faculty कौन है? अच्छा. Vaibhav Gupta, Dr. Vaibhav Gupta has taken, and he's also present with us. Thank you so much for joining, sir. And Dr. Jashkaran Singh also from IIT Mandi. So thank you so much for being part of that. It's a group of IITs, NITs, and triple ITs coming together and working together. Without taking much time, I would like to take this time to thank all of the speakers, thank all of our coordinators from various academies. Dr. Manoj and Dr. Kamlendra have done an excellent job, but there are other resource persons and other coordinators from other joint principal coordinators from other academies like Dr. S.K. Jain and others who have helped and monitored participants from their academies. So that's how this big number of about 750 participants could be handled. And please be patient. We will announce the quiz shortly so that you can take, and anybody has missed quiz 1 and quiz 2, you can take it forward and then we can conclude. Please, one caution I would like to say, most of us are picking up this quantum, but there is a slight disappointment. Sometimes we think that we are not able to really learn a lot of things, or we are not able to implement a lot of things. Please be patient. That's what I would say. Don't There is no shortcut for a fast food kind of a thing in quantum computing. Quantum computing will take time. Here we have my colleagues who have been working. Dr. Manoj has been working for last 7-8 years, and now slowly some things are, as he says, some things are visible as he works in quantum materials. Dr. Kamlendra works on quantum sensing, and as we see, it takes time. So participants, faculty members, research scholars, please be patient. And most of the time, the important thing is not the certificate, or whether excellent is there on good is there on the certificate. It's very easy to obtain all of these because it's a virtual program. But what I would say is, please focus on what has been taught, valuable information. And the information is there with you for life because YouTube is there, because the slides are there. You can continue to repeatedly listen to the lectures and pick it up. So if you have not understood immediately, you can take time and slowly take it forward. So with this kind of few words, I would like to hand over it back to Dr. Manoj. Professor Vineet Saula sir has also joined us, who is the Chief Investigator of the ACT Academy. So over to Manoj sir. Welcome, Saula sir.
Yeah, good afternoon and welcome, Saula sir. And
Yeah, good
yes,
afternoon. Thank you very much.
we would like to hear your words of wisdom and remarks regarding this course. So, Saula sir, please.
Yeah, thank you, Manoj. At the outset, I would like to thank you and Dr. Kamlendra Avasthi for putting your lot of efforts to run this program. And thanks to Dr. Pilli for spearheading the whole series in quantum. And there are many background efforts he is putting in. I think this is commendable. And I have nothing to say about the program because I'm also not even a starter in the quantum. But I would like to take this opportunity to thank all the speakers who have kindly consented to be part of this program, spare their valuable time, and I hope participants would have got benefited with their interaction, and maybe they can interact with them in future using their contacts they have provided, or our coordinators can provide those contacts on Canvas or the learning management system that way. Thanks to Professor N.P. Padi Saab for supporting us to run this complete series of quantum programs, which is about 10 programs. And we are looking forward to reward our all participants with a PG certification if they all attend the minimum 5 courses, plus whatever Dr. Pilli decides about the processing, a end-term examination and then evaluation based on that. Please follow that if you are aspiring for a PG certification which is there. And just to remind all of the participants that this PG certification program is actually in line with the AICTE recommendations for BTech minor started in quantum at many places, or you can also start in your institute. And this PG certification will put you in a kind of a advantageous position as a faculty to teach those subjects and other things. I think Dr. Pilli can also elucidate a few more things on that part. So I take rest here, and thanks for inviting me. I'm happy to be part of this all this effort. I don't remember my any concrete efforts here, but I'm happy that the knowledge is flowing and all participants are benefiting. Our coordinators are ready to support further also. And thanks again to all the coordinators, Dr. Pilli. And thank you. Thank you very much. Yeah, back to you, Manoj, Dr. Manoj.
Okay,
Thank you.
thank you so much, sir. And now I would like to invite our experts for some feedback. We have with us Dr. Vaibhav Gupta from IIT Mandi. So, Dr. Vaibhav, and yes, sir.
Hi, sir. I think your voice is breaking a bit.
Okay, so I would like to invite you for your feedback and remarks for the course. And if you can share your views on the course, some feedback also.
So I think for me, it was a very nice opportunity because I feel as a new faculty, we got an opportunity for the outreach, and it was a good opportunity also to teach in front of a large audience. So in a way, it was very nice. The next time, as is also suggested, that I would like to add some more caution papers or like some sheet of caution set so that participants can solve them and then we can assess them. And after the session, we can circulate it and then we can collect it back and then grade it accordingly. So, but overall, it was a very nice experience.
Okay, sir. Thank you so much. It was really nice to listen to your lectures. I also got to know many new things regarding quantum sensing because it is a very fast growing field. So there are regular updates here. Now, I would also like to request Dr. Jaskaran Singh to share his remarks about the course. Jaskaran sir, if you can please unmute and share your views.
So you can hear me, right?
Right, right. We can hear you.
Thank you very much for inviting us like, to give a talk here. Overall, I think this is a very good opportunity for people to learn about quantum technologies, since this is a very up and coming subject, and there are a lot of technologies upcoming. So overall, I think this is the best time for this FTP course, and with so many people already joining, so I think people know that this is going to be the next technology that's going to come up. And yeah, overall, I think it was very good. So thank you all and to this audience as well.
Okay, thank you so much, sir. Thank you so much for your appreciation. We'll keep doing such type of FDPs. As you mentioned, this is the need of the hour. So we need more manpower. We need a better dissemination of the expertise. Okay. So now I would like to request the participants present here to share the feedback, maybe from the chat box, but we will also like to listen directly to you. So please raise your hand and we will unmute you. Okay. So Dr. Gurunath ji, now you are unmuted. Please share your views.
Sir, myself, Dr. Gurunath. I'm from basically Karnataka, Raichur district, as in North Karnataka part. So I am so happy that I am with successfully completed all the courses, and especially all lectures are good. Maybe we are not up to their lecture level, but we enjoy like Professor Ashwath Babu class. that whatever he taught like a classroom, it's not that it is a virtual going on. Having all matrices and rows and column operations and Hedemond gate and Pauli matrices, and this is included in our syllabus. It will help for me as well as my student. Thank you so much, sir.
Thank you so much, Dr. Gurunath. Yeah, indeed, it was some topics which were quite new to us also. And we hope that with time, we'll get to know more about those topics and get familiar with those terms. And thank you very much that you enjoyed. This is nice to know. Now, I would like to request Dr. Bhaskaraya M. Now you are unmuted. Please convey your remarks.
Yes, sir. Good afternoon to each and everyone. Actually, this is a wonderful courses, series of courses. As it is mentioned, it is the seventh series, like QT-07 from MNIT. So actually, initially I missed a few courses, like 1, 2, 3, 4, but 5, 6, 7 I have been part of this, and it's a wonderful opportunity to learn all the courses. Basically, I belongs to uh, photonics, MTech photonics, which I did MTech applied optics from IIT Delhi, and I have been a faculty under RGKT, Andhra Pradesh. So in Andhra Pradesh, I think right now our MNIT is also MNIT Jaipur is collaborated with APSHI, AP State Council of Higher Education, to bring the courses together for a UG program, and we are already started the minor course in Rajiv Gandhi University of Knowledge Technologies. I am the course coordinator in RGKT, one of the campus named as RK Valley. So these courses, which are basically the continuously even though which I missed earlier, like a few courses which I mentioned, and we will be having an opportunity through APSHI as well as again from the MNIT. So it's this kind of series of courses. Actually, literally they have been helping a lot to many of the aspirants. And my personal opinion, especially about this course, is, as I mentioned, which my course, my Master of Technology, which itself is in the applied optics, and where I have done my MTech project, which is on optical trapping and manipulation of micro nanoparticles by which is optical tweezers. So nothing but it is a one of the sensing which are the techniques which we have used with the laser. So this makes this courses made me a lot like whatever we have studied earlier, and the real world applications now they have been rightly moving throughout the globe actually. So we don't know up to what extent it will reach, but it is going to be up to the infinite level. So that's what we are going to see. There is technology is being faster and faster, and it is going to the each corner of the globe actually. So for that, the India, especially from AICTE and MNIT and other where the National Quantum Mission, like many things, many initiations has been taken to make a large number of manpower, like human resources, for the development of the nation through the quantum computing. So I'm very happy for the things which have been initiated by our Pilli sir and our other all the all the names. I do not want to say that the limited people, because even I'm not I'm sorry, because I can miss many people if I tell the names and all. But it's being a wonderful opportunity to all of us actually for the next generation to make a more leaders. So thank you very much for providing such an opportunity.
Yeah, thank you so much, sir. Thank you. And it was really nice to know that you could gain the first-hand information on this topic, and you had the background in the optics. Then certainly it is very much related to your background.
Yes, sir. Yes, sir.
Anybody else would like to share?
Yeah.
Yes. Thank you. Thank you.
Thank you,
Bhaskar,
sir.
Thank you.
Thank you, Bhaskar, sir. So now,
Please raise your hands. Lakshmi Narasimha Rao, sir, please raise your hand.
yeah, Lakshmi Narasimha Rao, sir, please press this raise hand button. Then we can be able to unmute you. Yeah, now.
हाँ 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 ठीक है मेरे घर पे ना ठीक
Lakshmi Narasimha Rao, sir, we can't see you. Please raise your hand and we will unmute you. ऊपर से देखो.
Nivedita ma'am, you can unmute and speak.
Hello, am I audible?
Yes,
ma'am.
Yes, ma'am. You're audible.
So first of all, I would like to thank all the instructors, coordinators for organizing this insightful course on quantum computing. And I think actually this session is very much interesting, and yeah. That's it. Actually, I am enjoying quantum computing. Somehow or other, actually, I am able to complete all 6 sessions, last 6 sessions. And thanks all the instructors for contributing the excellent learning experience. And I am very much grateful for the opportunity to be part of this program. And I think actually quantum computing is a very vast course. So there are a lot of things to, but actually, anyway, actually it is a good experience, and I am thankful to all.
Thank you. Thank you.
Thank you so much, ma'am. Thank you.
Nivedita ma'am is also a PhD holder in physics. So we are very happy that ma'am you are there. And you
I have
attended all the 6 courses. Thank you so much. Yeah.
Yeah, I forgotten to introduce myself. So
Yeah.
I am Dr. Nivedita, and I have done my PhD from IIT Roorkee, and
Yes.
now I am also working at IIT Roorkee. So I am very sincerely attending all sessions. So
Yes,
that's
yes.
yeah, I am very much thankful to all.
Right. Thank you. Thank you so much.
Thank you so much, ma'am. Yeah,
Yeah,
Dr.
are you able to hear me, sir?
Yes, very much.
Yeah.
Thank you, sir.
So myself, I am Lakshmi Narasimha Rao, working as Senior Mechanical Engineer in National Remote Sensing Center, ISRO, Hyderabad, sir. I am attending this, I attended this FTP for the first time in quantum technology. And I sincerely would like to thank EICT Academy and Core and all the organizers on the screen and all the distinguished speakers. However, I can't refrain from myself by mentioning some of the names, especially Dr. Manoj and Dr. Kamlendra Avasti taking their time on weekends, on non-working days, and taking out organizing in a very systematic way. And coming to the speakers, Dr. Avasti Babu, Dr. Rajan Jha, Dr. Tarun Datta, and Dr. Vaibhav Gupta, and Richa Goel, Dr. Diskaran Singh, all the speakers we find very good content. And also this also I felt like at the end of the program, although I was feeling that I missed QT1 to QT5 series. Definitely I'll sit back and I'll go through all the content provided. And also it is also this FDP, also for the namesake it may be FTB. I truly feel that it is a fulfillment of an NQM objective and building the capacity building by building the trained resources. So in turn, all this faculty is going to train and enrich entire India. So definitely it is a very valuable uh, value addition work to the society. And and also, as somebody was telling today, Dr. Richa Goel was also mentioning, if you think that you understood quantum, it is illusion. And so that, and also many times Dr. Avasti Babu, I should also thank him many a time, because I'm a mechanical engineer. First time I'm joining this, attempt exploring office development works. I used to ask many questions, but still all the speakers, all the organizing team, were very patient with me and attended all my, they clarified all my doubts. So as you know, there is one saying, I quickly complete, polishing a gem only makes it shiner better. So I would also bring to all the organizing team members few important things that initial there was small hiccups were there in whether WebEx or Canvas, where to which one to use to log in, and also accessing the uploaded content. Also, the dashboard is not so user friendly. Some if you can pay some more attention, definitely it will be very enriching experience. And also we were there was one WhatsApp group that focal point admin was Mr. Bhaskar. Of course, I appreciate time to time. Sometimes he's sending message, but the person who is attending this session, or if he is part of the admin of the WhatsApp group, there will be better communication to the updates or problems we are facing. The and second thing, and definitely because which is a very evolving and very demanding area, FDP of successfully conducting the FDP programs. Definitely, I wish you'll you'll come out with some more interactive platforms for the faculty, the trainers, speaker participants to get interaction with the speakers or the faculty who are trainers, so that better interaction and better clarification of the doubts. However, I'm very extremely happy, and if you organize any other FDP, we are ready to join, because such is that is the impact and impression created with the organizing team. I truly once again thank Dr. Manoj, Dr. Avasti Babu, and Dr. Kamlendra Ashwati. Thank you so much.
Yeah.
Thank you so much, sir.
Yeah. Please note that QT-03, if you have missed, other participants also, QT-03 course will be starting from 26th October. We will be sharing the link today. So in case if you are interested, those who have missed QT-03, it's a programming course. If you are, we will also do a little bit on quantum machine learning and also on quantum algorithms. Lot of different simulators will be exposed. Please look at that. The syllabus will be on QT-03 and QT-04 together. Simulations, cloud cool things and all you can try to look at. Yeah, actually we don't take feedback here, but definitely because we have completed 6 courses, we will shortly send you a link about what all you have benefited. So please wait. We have not yet prepared the feedback link, but we will send you shortly. You can do that, right? Yeah. Rashmi ma'am, you can unmute and speak.
Hello, good evening, everyone, and the organizing committee. Thank you very much for a wonderful event that you have organized. And then I would like to say special thanks to Arjun sir. Every time, as and when I sent a message with respect to that platform, with respect to errors, with respect to the platform or quizzes, without notifying the time and all, he responded properly and he guided well. And you used to get many queries from the huge number of participants, so with good patience, you have resolved all the issues. But through this, I am making a special request. We need a proper details about that PG certification. And then just you have mentioned, sir, you the QT 3 and 4 is combining together, and you are hosting an event by next week and all something like that. Is good enough to added the credits for the PG certifications, or should we take separately Q3 and QT 4, and we need these kinds of more details. Hello, sir.
The hardware part is there in QT-04. So that part we are not able to cover because we need hardware lab, which we will do it maybe once the UG labs are set up. NQM is planning to set up 50 to 60 labs. So we'll do that, right? So don't worry about that. Regarding QT-03, QT-04 was merged in the previous time also when it was conducted. So as you see, QT-01, 02, 04 was together, though it was named 03, but 04 content was covered. Then we did not have an exclusive QT-04 course. If you go to YouTube and search these courses, you can see the sequences. Maybe in the group, we will post all the sequence of the courses already covered because they are still on YouTube, open for everybody. Anybody can take the course, right? Not the course, anybody can view the videos. So QT5, QT6, QT7, these three courses are conducted. QT-08 will be conducted shortly. We'll announce that also. That presently we have postponed it. It was supposed to start in about 2 weeks time. So sometime in December first week it was supposed to start, but November first week it was supposed to start, but we will announce it shortly. But regarding the QT certificate, those who completed 6 courses, that is 18 credits, and those who have attended a face-to-face meeting in one of these centers, our 7 academies are there, and then more than that, we may have other centers also for the convenience of participants. We will open it. So presently, PG diploma could have been easily awarded from MNIT Jaipur, EICT Academy. But we are looking at a more prestigious certificate which will be useful for you. That is PG certificate. Professor Saula sir also mentioned just now. So that we are submitting our MOU to AICTE, and shortly we will do it. So for what is AICTE, what is PG certificate? Just go to AICTE website and type PG certificate. You will see about 60 institutions are offering PG certificate where there is a 5-month online interaction and 1 month offline interaction. So it is already started. Last year it started. This year also some more institutions will be added. But when we approach this with these quantum courses, sir, we are doing these quantum courses and VLSI courses and AI courses and blockchain courses, IoT courses, like that we are doing across various academies. Chairman AICT was very much happy, and he said we will try to offer the PG certificate to all these participants, but they will have to do some kind of a contact program in some of these institutions across India. So once we put up those modalities, we will definitely share within the group. And please be connected. Please don't leave the group because that is one way. Of course, we'll send an email also. That is definitely a way to connect with you. So don't worry about that. Just give us some time. Meanwhile, if somebody has missed QT-01 and 02, which is already conducted by APSHE, also for Government of AP, and now it is open to others, we are going to come up with a MOOC course. It will be available online. The certificate value of whether you are doing an APSHE series course or an MNIT series course or tomorrow a MOOC course, the certificate will be same. And we are also sending a letter across to National Quantum Mission to give a recognition for all the courses that have been conducted. Only one course they have given as a certificate. Now we are going to extend that, and we are just waiting. Somebody was asking about the certificates. Please wait till Diwali holidays are over, because if we get the confirmation, we will include NQM logo also in your certificate. So please wait for the certificate. I hope Manoj sir will announce the schedule of the quiz 3 and the certificates as well when they will be released. Please be patient. So I hope I have covered some of your queries. I'm part of the QT-07 group. So if you have any still more questions on the certificate, you please ask in the group. I will clarify further. Thank you.
Thank you, sir. Thank you so much. Yeah, there are some more feedback.
Murthy, sir.
Murthy, sir. Dr. Murthy, please unmute yourself and we can talk. Murthy,
Yeah,
Dr.
hi.
Murthy, permission. Yeah,
Yeah,
please, sir.
yeah. I'm Murthy, not a doctor as of now. Actually, I'm pursuing my PhD right now. I am working as a vice president in one of the largest bank in US.
Okay.
So this is my 6th course as part of this one. So I attended all the courses, and as part of my PhD thesis, I'm doing with MS Ramaya in Bangalore. So the course and content and everything is really good. And the support through WhatsApp as well as through the Canvas, everything is really amazing. Yeah, I could see that at the time to time, some of the courses, new participants, when they come, they are facing some issues. But once it is resolved, it is fine for everybody, because I never faced, except the first one in the initial hiccup, everything else went smooth. And I really, thanks to Dr. Pilli, it was Emmanuel Pilli. So it was really great. And the organization and all other things and are really good. And especially when it is coming to the materials, this course material was really awesome. About the quantum sensing, the papers, the 2 papers, and also a class notes kind of a thing that is really good. So I'm looking forward for the other courses as well. And yeah, it is really good. Only thing is that since I'm working in the timing, so I could not attend the full-time courses in live. So I used to go through YouTube and other things, because 2 to 4 is the prime time for any corporate. So, however, it is really good, because we cannot say that this is organized by college and then you have to be in the college timing. Yeah, I should agree. I should appreciate that. However, when it is coming for the corporates like us, yeah, it is only the either YouTube or some other things. That is what it is actually making us to go through these courses. And really hats off to you and your team, and for creating this awareness among the quantum community. Thanks a lot.
Thank you so much for your appreciation. And it is true that the timing we have to keep 2 to 4, and this time also during the weekends, because of the Dasara holidays and the Diwali holidays coming up, we squeezed the course days. And that's why the timing was a little bit
Right.
extended.
I understand, Murthy sir. Definitely being a vice president, most of you would not have heard. I am in touch with Murthy sir, so he's a senior leader, and that is why I'm so excited actually to conduct so much effort into the course, because there's so many well qualified and well placed people still following the course. We will definitely consider. Please don't worry about the attendance requirements. We will definitely relax. And Professor Vineet Savla sir also we have been discussing about how to manage the attendance, and he has asked that let us consider this as a self-paced course. So let's not really insist on attendance, but then definitely we will focus on being regular to the classes. That's what we can do. So we will be a little open as far as the attendance is concerned. I'm sure many of you are going back to the YouTube videos over and over again, not only when you missed, but otherwise also. And I'm very happy that you're taking forward. So, sir, please continue to follow. And if you have missed any of the earlier courses, the AppShare course will be available. The QT-03, the programming course will be available for understanding variety of simulators. Thank you so much. Thank you, Murthy sir.
Yeah, and one small query is like the blockchain courses are already started or going to start?
Sir, actually one course is over in
Okay.
IIIT DM is spearheading the blockchain, IIIT DM
Okay.
Jabalpur. I will definitely post especially the PG certificate thing once it comes up. I will post it, sir, so that you can take it forward, right? Yeah, we'll do that.
Yeah, thanks a lot. Thanks a lot.
Dr. Pilli,
Thanks.
just information for blockchain.
Yes, sir.
There will be that program will be in offer in the winter's courses, November to February. It's going to come from the Jabalpur only. Yeah.
Yeah.
It will jointly organized. Yeah.
Sure. Between November and December, the schedule will be announced. So I will share with you the brochure. I will share with you so that those who are interested, there is going to be an AI stream. There's going to be a blockchain. There's going to be a VLSI stream. So please, those who are interested can take those courses. It will be jointly conducted by all 7 academies, and I think we have Jain sir also from IIIT DM, right? Jain sir is from IIIT DM, right?
Yes.
So Jain sir was here for some time, I think. Thank you, Saula sir, and yeah, participant. Yeah, over to Manoj.
So you can take them.
One more, two more people.
Yeah.
Sirisha madam.
Sirisa madam, you can now unmute and share your views.
Yeah. Hi. Hope I'm audible.
Yes, ma'am.
Yeah. So I'm a postdoc from University of Michigan. So I take special interest in these courses and I do regularly attend. But unfortunately, I couldn't attend the earlier courses, QT series courses. I've lately attended communication and sensing. So I'd like to attend the further FTP courses also. The reason that I'm attending these courses is to transition from I'm basically a material scientist. So my postdoc work is on materials. So I'd like to transition to quantum materials. So that is my prime interest that I'm joining this program. So yeah, I have one suggestion that how about having some experimental hands-on experience, because I've seen that along the course, I've seen there are many experimentalists like professors who have been talking about their setups and various kinds of experiments and outputs. So I feel that it would be quite interesting to have some kind of hands-on experience.
Yes, sure, madam. We will plan something with in offline mode also with some hands-on experience. And the thing is, as of now, very few people are working who have setups and all. So we'll be looking forward to collaborate with them to manage something, some more hands-on experience for the participants.
Yeah, the hardware lab per se will be coming up, ma'am. So we are waiting for others who will start the hardware lab. And once the hardware lab is ready, then we will take it forward, right? Yeah.
Oh, sure.
So definitely we'll, and I think some of the courses like CDAC, ma'am, Anindita, Dr. Anindita Banerjee.
Yeah.
So she had shown a video of how that is. So maybe we'll try to look at some such, what do you say, where you can see live what's actually happening, and we'll try to do that. Yeah, we'll take it forward.
Yeah.
Thanks.
Yeah, great. Because being an experimentalist, I'm more inclined towards the experimental kind of work.
Really?
And one more thing, as Professor Vaibhav had mentioned, that having continuous evaluation would be a more, what do I say, focused and strict evaluation. So rather than having 3 quizzes, it would be nice to have some continuous evaluation towards the end of the course or like anything. This is a part of feedback.
Yeah,
And,
there'll be one written exam actually, which will encompass these 5-6 courses. So that will be the one which will actually make you eligible for the PG certificate. So that at that time we will try, when there is a face-to-face interaction, we will definitely also show that this part also, ma'am, demonstration part also, we'll try to make it possible, right? We'll try to do that.
Great, thanks. And one last question. When is the quantum materials series going to begin?
Yeah, actually it is as of now placed in March, but we are trying to see if we can do one in November. So that will complete all the 4 verticals actually: quantum computing, quantum communication, quantum sensing, and quantum materials. So we just are waiting for an approval. So immediately we will announce. Otherwise, it will come up in March. Yeah, that's the thing.
Okay, great. Thank you. Thank you for the organization. It looks pretty well and well organized. Thank you for the support. Yeah.
Thank you. Thank you.
Thank you so much, ma'am. Thank you.
Yeah.
Yeah, Rashmi ma'am पूछ रही थी. Rashmi ma'am and then Veeramanikam sir. Yeah, maybe we can be brief. Yeah, thank you.
Rashmi madam, now you can unmute and share your views.
Not Rashmi B and madam, but Rashmi ma'am only. Question maybe last chat. और एक सर वीरमानिकम सर भी कर दिया ना उनको. वीरमानिकम मैम. Yes. Rashmi ma'am, please unmute and speak. Veeramanikam sir, you can also unmute and speak, one of you.
Good evening to everyone. So I am attending this quantum course last 4 series, 4 certifications so far completed. So thankful to the organizing team for their effort. For this sensing session, even organizing team conducted on Saturday, Sundays also. Thank you, sir. Thank you very much. So during QT2 in APCSCH, Sir told about quantum algorithm. Can you explain about that, sir, once again?
Yes, actually, National Quantum Mission asked us to elaborate and increase the what do you say the levels that we can look at. So we are going in this sequence of QT-01 to 11. But people who have picked up a lot on quantum computing, that is QT-05, the next course comprising of all these four verticals, quantum computing, quantum communication, and quantum sensing and materials, the next level course will be quantum algorithms to start with. So what you can say is all those who attended QT-05 and the previous courses like 3, 2, 3, 5, those who attended, they will be eligible to attend this course called quantum algorithms. But yeah, it will be restricted, so it will be limited number that we will take up. So that is what we are looking at, because government is looking at people who will run the get involved in the projects that and then propose new algorithms. So we want them to be trained on that. In fact, IBM also, TCS also, they're all very eager that not only that we train them to teach the courses, but we want some people who will actually do projects, research projects. And there are so many offerings. So yeah, please, the algorithms close is not announced. We are still working with few IITs and IBM. We'll shortly announce. It will come up, and yeah, because we are already loaded actually. That's why we are not able to do QT-08. We have not noted. But then yes, please be patient with us. We want to really take it forward. Hopefully sometime at the earliest we will announce. But the news will come across all the WhatsApp groups that are there already with us. And apart from that, all the emails that are registered with us, we will definitely communicate any course that is offered. Or in fact, other people are also requesting me. We are also floating that information also in the WhatsApp group. So please take it forward. Right. I think we can take.
So
Yeah,
I have
sure.
completed all the course except QT3. So coming
Yeah,
next session, QT3 I can do under AP.
QT3 you can do under AP. AP, it is now not going to be an AP.
Remaining already I completed everything.
Right. So QT-03 you register set starting next Monday, that is 26th, right? Post Diwali.
Thank you, sir. Thanks a lot.
Yeah, two people last we'll take, I think, Mr. Khaja and Mr. Oblesu. Mr. Khaja and Mr. Oblesu, one of you can speak.
Rashmi madam.
Okay, Rashmi ma'am can speak. Yeah, please go ahead.
Hello, sir.
Yes, ma'am.
Yeah, sir, this is Rashmi, Professor Rashmi from the Pillai College of Engineering. Actually, my background is a computer engineering, but I am much more interested in the quantum computing and the quantum sensing. So thank you very much for organizing such a wonderful FDP. And the session was very informative. But in the future, I want to attend some different like machine learning and machine learning, blockchain, and other topics related FDP. So, is this possible?
Yes, ma'am, it is possible. You have to visit our MNIT online registration site. The list of programs that are going to be offered will be there. So you can look at that. Presently, there is a slowdown, but we will start the series again. The announcements will come from November, mid-November. They'll go until February. They are called the Winter Global Online Programs. So 7 academies will join together and run the course. So please wait for that. I will, once the links are coming up, I will just mention in the group that you can go to the MNIT website and you can visit IIT DM Jabalpur, NIT Patna, IIT Roorkee, IIT Guwahati. These are the sites where EICT academies are there. 7 academies are there. IIT Kanpur. So all these sites can be there, but MNIT will also be part of these global courses. So announcements will come into these respective groups. So please be patient. So whenever you would like to look at, please visit our website. of the EICT Academy, you will be able to see the upcoming courses. The schedule will be there. So blockchain courses, AI series, blockchain series, VLSI series, and quantum series. You can please look up for these courses. Thank you. Mr. Khaja, and lastly will be Oblesu. Oblesh sir, Khaja sir.
Sir, one more query.
Sir.
Any plan for national quantum mission to bring these things to school level, 11th, 12th kind of students?
Sir, presently, some of the governments are taking them to the college level. So about 50,000 students will be offered some course like this. That's what they're doing. And NPTEL is also going to offer this course, which courses on this thing for students also. So that is one of the reason. But 11th and 12th, I'm not sure. But presently, I think as of now, it will be difficult also for them at a simple awareness level. We will be able to do. So presently we are training the faculty. That's what we can look at in AP programs that you look at APSHE. The programs are basically for all streams, not only for computer science and physics and mathematics, but all streams. So many of them are from management, commerce also. They're following and they're trying to pick up. They're trying to put the effort. So their students, they will try to offer, but hopefully we are looking at 11th and 12th, at least the awareness level programs can be done by the faculty who are already trained. Most of you have the material with you. So I think we should take it forward with 11th and 12th classes. Yeah, I think Khaja sir, you can speak. Dekho, Khaja sir ka message bheja.
You can also unmute the first one.
पहले तो unmute करो. एक बार Khaja को search. Mr. Khaja, you can search. Yeah, Mr. Obeleshu, you would like to say something? Yeah,
Yes, sir.
Yeah, please go ahead.
Am I audible, sir?
Yes, sir. Yes, sir. Please go ahead.
Yeah. Thank you, sir. Yeah, this is Dr. Obleshu from Vidyajyoti Institute of Technology, Hyderabad.
Yes.
Regarding this QT-07, first of all, I would like to thank all the organizers. First of all, our department is conducting on FDP, sir, evening 6 to 10. You allowed to me to share in our WhatsApp group. Thank you so much for that. Now coming to this quantum as of this QT-07, excellent, sir. All sessions are attended. Now as of bit expecting some exact for executing this quantum algorithms, IBM, some kind of free platforms are there, right? A little bit of hands-on session, little bit I'm expecting, sir. That's what a simple suggestion. Thank you so much for entire my MNIT Jaipur. Thank you so much.
Sure. Thank you, sir.
Hello,
Thank
sir.
you.
Hello?
Yeah, please. Yeah, please go ahead.
Yeah. Afternoon, sir. Am I audible, sir?
Yes,
yeah,
sir.
audible.
Khaja sir, you are audible. Yes, please go.
Yes, sir. Thank you very much for giving me the opportunity, sir. I am very grateful to everyone involved in organizing and conducting the QT-07 Quantum Sensing FDP. It was an excellent learning opportunity, and I deeply appreciate the combined efforts that made it successful and informative. And the entire MNIT team led by Emmanuel sir and each and everyone. So as it's a team work, and the last that is a successful thing that is carried out. And one thing from my side, as everyone is saying, there is a lagging with respect to labs, sir. So like in BTech, we are providing the concept of virtual labs. So not just for doing small programs on research oriented side also, if some sort of virtual lab with some high end is provided, it would be beneficial for the researchers like me who are carrying out the research with respect to quantum approach. That's a small request from my side. Hopefully it would be considered.
Sure. We will take up at least the simulation part that will be virtual labs. We'll try to give it in the algorithms course. So please look out for that. Right. So, but that will be a little higher. So that's why if you have covered all these, and this time in QT-03, we are trying to enhance the number of lectures also, and also give more on that. Yeah, please, please rejoin the QT-03 course because the lectures will be on YouTube. You don't have to register as a participant if you already completed QT-03. But please follow the lectures,
Yes,
right?
sir.
So that's what I would suggest.
Yes,
Thank
sir.
you.
With this, I have completed successfully QT-7, sir. All
Right.
the 7 series of quantum.
Very good. Very
Hopeful
good.
that
Very good.
for the upcoming sessions also I could join and complete all the scenarios and grab the certificate that is being mentioned.
Right. Sure, sir. Definitely.
Thank you.
Thank you.
Thank you, sir. So now, I would like to invite Aswat sir. Actually, he's with us. He's one of the leading contributor to this course, leading expert in this topic. Aswat sir, please share your views regarding the QT-07.
Hello everyone, very good evening. Sorry I could not join in time. So I'm just driving. Let me cut down the video so I can speak.
Yes, sir.
Thanks to Emmanuel sir for reminding me. It's I was like very pleased to know people participants from US. That is amazing. I'm not demeaning our Indian participants. They are also from eminent institutes and doing some great stuff. And with a passion to quantum, they joined this FTP. That is amazing. And indeed, it's a privilege for us, the resource persons, to share whatever understanding we had with this kind of versatile participants. We like for myself. Let me on behalf of myself, I would like to express is I would like to keep in touch with all these people. So it's like a kind of a collaboration I would like to treat so that further research we can do together, right? It's not like we taught something as in the sessions. It's not like that. We had shared our understanding with the participants. Now, having the understanding, let's go hand in hand for the further research. That is how I see. So I congratulate all the participants for successful completion of this particular FTP and also all others FTPs. That is also amazing job. From my end, I would be very pleased to see participants like they felt satisfied with the knowledge they gathered, and also they felt it's very informative more than understanding. So it's not easy. I agree. It's not easy to gather everything what has been taught in 40 hours in a 20 days time. It's not that easy. And moreover, it's advanced stuff, not just the fundamental stuff. It's advanced sensing part. And this is a field which is going to pick up very, very soon after communication. So those who are interested, I would request them, please keep an eye on this field. Okay, for people from whether from medical side, material side, one of our Michigan, madam from Michigan, postdoc. Amazing story to hear from US. She is attending the event despite the time schedule. It's a completely opposite time schedule. I agree. That's for the participants. Thank you so much for the opportunity. Without you, it is not been possible, right? Tuning in time and asking some amazing questions, triggering a better understanding in our resource persons themselves. That is something I really very pleased with. And also, I take this opportunity to congratulate the entire MNIT team, starting with Billy sir, and then Manoj sir, and Kamlen sir, Avasti sir, okay, all the other organizers for the giving the opportunity and also conducting this amazing FDP series without any hiccups. It is going and going on. So it's amazing. It's not easy, I agree, because with a single FTP, how much work would be there? And these things are like a 20 days a marathon FTP is being conducted.
what kind of coordination is required, I can see.
Link
So, yeah, and all, overall, I would like to thank them and also congratulate all the entire team. And I would like to keep in touch with all the participants. And best of luck for the future other FTPs. And very intriguing suggestions were also given. Okay, I was straight away thinking about everybody is thinking about teaching lab, teaching something and conducting events. Why can't we have a virtual lab, right? Right, that's an amazing idea. So I would be thinking, and I would be thinking with like discussing with some of our friends in this direction. So see, we are getting amazing output even for the resource persons to the FTP. So thank you for the participants and the organizers for that. So I'll conclude here and with thanking MNIT for the opportunity and also AICT and the NQM for the platform to have for us. Okay. Yeah, a happy Diwali to all the participants and the organizers. So thank you once again. I will hand it over to the organizers.
Thank you, sir. Thank you so much. Happy Diwali. A very happy Diwali to you too, sir. And yes, it was a really nice experience learning from you. And almost all the participants, they really appreciate your lectures.
Thank
Yeah,
you,
many
sir.
of them, you have missed that part actually. That's why I called, because many were expressing their thanks to you. And you have taken a major load in this course.
Yeah.
Yeah.
While for the participants, I would like to inform Ashwath sir was teaching in QT-02 in APSHE and QT-07 here. Some days he taught in both the courses in the same day. You can imagine the passion with which he has done. Thank you, Dr. Ashwath.
Thank you, sir. Thank you so much. Thank you for the opportunity. Without your support, sir, please, sir, it would have been not possible.
Right, we managed. Right. Thank you, sir.
Yeah.
Okay. Thank you once again, sir. Thank you. I think now. Okay. Okay, so it was really nice, and in fact, it is very motivating to us to have some positive feedback. At the same time, we also appreciate your suggestions, and we'll try to include all those suggestions in our upcoming courses. And these FDPs will go on. Pilli sir is here, and Saula sir is here. So we'll try to bring up more such type of courses from our side. And now I would like to hand over to Dr. Kamlin Awasthi, my head of the Department of Physics, and also one of the joint principal coordinator to this event. Awasthi sir, please.
Thank you, sir. So now we come to the end of this FDP that we started on September 26th. I agree, maybe the complaint or the suggestion from the participants really very challenging to complete the FDP within this time. It has so many holidays. This is the reason why we kept session on Saturday and Sundays. Sometimes we have to like match as per the time zone also with the speakers. Sometimes we have early morning or like late evening. So thank you once again all the participants joining for the session. So I also thank my other academy from NIT Patna, IIT MD Jabalpur, IIT Guwahati, IIT Kanpur for joining hands together for organizing this course on quantum sensing. I'm thankful to my this chairman of EICT Academy and director MNIT Jaipur, Professor N.P. Padi, our chief investigator EICT Academy, Professor Vineet Sahula sir, coordinator EICT Academy, Dr. Nanda, co-chief investigator, Professor Love Bhargava, Professor Pilli is here, Dr. Ravi Madela sir, for your all support for organizing this meeting. I'm also thankful to other principal coordinator and joint principal coordinator from other institutes for your help and means coordinating this session with the participants. And uh, it is again, because this is a very new course for us also, so it's really to have it cover all the spectrum on this quantum sensing. We tried our best to invite the speakers means from the reputed institute who are having background like in quantum sensing, and I am thankful to all my speakers starting from Dr. Rajan Jha, Dr. Vaibhav Gupta, Dr. Jaskaran, Dr. Arup Samanta, Dr. Kausalya, Dr. Asad Babu sir, Dr. Ramchandra Rao Ella, Dr. Tarun Datta, Dr. Richa Goyal, and Dr. Noman for your time and consent to be part of this FTP. And this is not possible without continuous help and support from our staff from EI and CT Academy. So I'm thankful to Ms. Geeta, Mr. Deepesh, Mr. Ramesh, Mr. Manish, who helping us to set up all the things like from starting the lecture or after ending the lectures. We have support from our PhD students also, so because they are also working here to manage the session, Mr. Sachin Sharma, Ms. Deepika, Mr. Rahul Misra. So I thank once again everyone. If I'm forget name, please excuse me, who have supported this FDP directly or indirectly uh, to make it like a success. As mentioned earlier, we are coming up with the new series, new FDP. So be in touch, and we wish you all the best and look forward to meet you in other session of this quantum sensing. Thank you very much.
Yeah, I think thanks are due to the participant who have joined in large numbers.
Sure,
and of
sir.
course, thanks are due to you, Dr. Manoj and Dr. Kamlendra, for really putting your efforts for the whole program. And I think it is always less of a thank you, Dr. Pili, who has been doing this for almost a year that way. And I don't, I expect that he will not get tired till the whole series is over and each certification is given. Yeah. Thank you all the speakers also. And thanks for inviting me.
Thank you, sir.
Thank you.
Thank you so much.
Thank you,
sir.
sir.
Thank you, sir.
Thank you.
Certificate or quiz grams.
Okay, so coming towards the end, and I also thank each and everyone who participated in this course and who supported us by any means. Now, there is one small announcement regarding the quizzes. So, as we all know, now Diwali break is coming up from tomorrow. So, quiz 3 will be set up and open from 6 p.m. today till 6 p.m. next Friday. Not only quiz 3, we will also open quiz 1 and quiz 2 so that whoever missed quizzes, they can uh, attend those quizzes, they can attempt the quiz as per their own convenience. Okay, so for 1 week, all 3 quizzes will be open. The next thing, once we complete all 3 quizzes, then we can issue the certificates. Basically, certificates will be issued more or less after 10 days from today. So we'll try to issue the certificates by 27th. It will be Monday. Okay, Monday evening, possibly. So once all the quizzes are evaluated and we grade according to the quiz and attendance, we'll issue the certificates. And yes, sir, anything?
Regarding the Canvas access, it will be there definitely till December. We will keep on extending. But yes, please download the material and keep them ready with you. YouTube content will always be there, but your lecture notes or slides, please download and keep it, right? So I think that should be. Thank you.
So Thank you, everyone. Thank you once again. And if there is any query, any concern, any issue, please feel free to contact us, drop an email. The WhatsApp group is also active. You can approach us anyway. So, thank you and wish you all a very happy Diwali. And now, I think I would like to conclude here, close the session. Thank you. Thank you once again.
Thank you all.
Thank you all. Bye.
Thank you all.
Happy Diwali to all of you also. Yes. Happy Diwali. Right. बंद कर दो।